Alright, so today we're going to be starting where we left off yesterday. So yesterday we talked about the three inverse trig functions. Okay? And we talked about we restricted their domain and then we found their domain and range for their inverse functions. Okay? So today we're going to talk about exactly which quadrants our outputs come from. Okay? So for instance, arc sine and arc cosine, you can input any value from -1 to +1. But both of those functions give us different outputs. So yesterday we found that the range for these, so for instance, the range for arc sine is from -pi/2 to pi/2. Okay? So that basically means the quadrant 1 and quadrant 2. So these two quadrants right here, that is where you're going to find arc sine. Okay? Because when we label our unit circle, if this is 0 right here, this is pi/2, and this is -pi/2. Because if you remember, when we do angles, positive direction we go counterclockwise, negative direction we go clockwise. So this arc right here, this part of the circle, that's the quadrants that we are going to get outputs from for arc sine. Only in quadrant 1 and quadrant 2. Okay? So when we look at this, this is quadrant 1 and this is quadrant 2. Okay? Sorry, 4. So arc sine gives us quadrant 1 and quadrant 4. Arc cosine will only give us back values from quadrant 1 and quadrant 2. Okay? So quadrant 1 and quadrant 2 are for arc cosine. Quadrant 1 and 4 are my sine. Okay? And then arc tangent mimics sine and gives us back first and fourth quadrant as well. Okay? Now notice we don't get anything from quadrant 3. That's because nobody likes quadrant 3 because it's so negative. Okay? So quadrant 1 and quadrant 2 for cosine, and both arc sine and arc tangent give us back quadrant 1 and quadrant 4 answers. Okay? So if I use any of the inverse functions, notice I will not get anything or any kind of values back between pi and this is 3pi/2. Okay? Between those two values, none of my arc sine will give me back values from there. Okay, and this is really important because when we start to evaluate these functions, you need to know where they're going to output from. Okay, so this is how the functions work. All right, so arc sine of -√3/2. Okay, so before we do that, we're going to talk about first this one. Okay, the way the sine function works is you input an angle measure, a radian or a degree. Okay, so you input an angle and it gives you back a unit circle value. It'll give you back a number between -1 and +1. Okay, so we've been doing this for a while. The sine at 5pi/3, okay, 5pi/3 is in the fourth quadrant, so it's negative, and this is the square root of 3/2. Okay? So the way the sine function works is you plug in an angle, you get back a unit circle value. The arc sine function is the inverse of it. So you input a unit circle value, like -√3/2, and the arc sine will give you back the angle measure where it happens, and it'll give you back 5pi/3. Okay, that's how the arc sine, arc cosine, arc tangent function work. You plug in a unit circle value, it gives you back a angle measure. Okay. The problem is that there are two places, though, on the unit circle where sine is negative root 3 over 2. There are technically, it happens at 4 pi over 3 and at 5 pi over 3. Okay? Both those places, sine is negative square root of 3 over 2. But remember, the arc sine will only give you values back from quadrant 1 and quadrant 4. So the arc sine will never give you back that value. Okay? It'll only give us 5 pi over 3. Does that make sense? So basically that brings us to this point. Eventually we're going to start solving trig functions. Okay? Which is different than the inverse trig function. So basically this first part we've already done. We know that this is 5 pi over 3. Versus this right here, when we go to solve Trig's functions, this is kind of like what we did when you solve x squared equals 4. There are two values here. What can I plug in for x? When I square it, I get 4. We get x equals positive and negative 2. There are two values there. Because we know the solutions for this could be positive 2 and can be negative 2. Same thing here. When I ask you, hey, sine theta equals negative square root of 3 over 2, where does that happen? If I'm saying, hey, find the solutions that make that true, there are in fact two places that that occurs. And we just talked about it. It's at 4 pi over 3 and at 5 pi over 3. And this is where the calculator fails us. So if I had actually put in the calculator, and you could, the way the functions work, I could have taken the arc sine of both sides like this, and I would have gotten theta here. But here, the arc sine would have only given me back one value. If I didn't know that there'd be two solutions to that part, then we'd be in trouble because we'd be missing solutions. Now, also technically, since sine is a cycle function, a periodic function, there are a ton more answers for that because you could basically, every coterminal angle would also be a solution. So generally we stipulate between 0 and 2 pi for these solutions. But you can see where this causes problems. If we don't know the function itself, if we're using the calculator to solve problems like this, we're going to be missing solutions. If I don't know the domain and the range for arc sine, it causes problems because I'm thinking the calculator doesn't know what it's doing. Okay? So just that alone you need to know. So let's do some practice. Okay? So the arc tan at 1. So we're going to be evaluating these, and basically, just like when we talk about finding trig values, like for instance, as an example, sine at pi over 2. What that really says is I want to know what is the y value, because sine is the y value, at pi over 2. That's what this trig function says. The inverse function is saying where is tangent equal to 1? What angle measure? That's what arctan is asking us. Where is tangent? What angle measure gives us tangent of 1? There are two places, but we can only use the first quadrant one. So it's pi over 4. And this is what I'm talking about of knowing your unit circle values. If you don't know your unit circle values, then it makes this very, very difficult. Because now we're going in reverse. We need to know what angle measure gives us 1. Okay? Same thing right here for arc sine. So this is saying, hey, what angle measure is sine square root of 3 over 2? And it can only be from quadrant 1 and quadrant 4. Well, in quadrant 1, sine is positive, and square root of 3 over 2 is at pi over 3. Okay. Arc cosine. So we're saying, hey, where is cosine negative 1/2? Well, remember, arc cosine only is in quadrant 1 and 2, so we know we're in quadrant 2. And what angle measure is cosine negative 1/2? That's 2 pi over 3. And of course, you could always check yourself by doing the opposite, saying, okay, what is cosine at 2 pi over 3? Well, that's negative 1/2. So you could always use those trig values that we've been studying to go backwards and check your answer. Okay, so let's look at this one here. Arctan at negative square root of 3 over 2. Okay, again, I know arctan is only in quadrant 1 and 4, so I know this is a value from quadrant 4. And tangent is square root of 3 at the pi over 3 angles. So what is the pi over 3 angle in the fourth quadrant? 5 pi over 3. Okay. Arc sine at square root of 2 over 2. So what angle measure is sine square root of 2 over 2? Yep. Pi over 4. Arc cosine at the negative square root of 3 over 2. So we know we're in second quadrant, and that is 5 pi over 6. So again, just like square root functions, we define square root function answers or outputs based on squaring function, the quadratic. Like, you know that the square root of 4 is 2 because you know 2 squared is 4, and they are inverse operations. It's the same thing here with trig again. The only way I know that arc cosine at negative square root of 3 over 2 is 5 pi over 6 is because I know that cosine at 5 pi over 6 is negative square root of 3 over 2. So we're defining the inverse function by its regular function, and that's kind of how it works. Now, on Monday, we're going to start doing composites of these, and I'll kind of give you a little bit of insight. We're going to be starting to do problems like this, which aren't hard, but you definitely need to know your unit circle values.